All, Vinod here from Entrance Engineering Academy. Before going into the video, I just want to say a few things about Entrance Engineering Academy. So, EEA is an online gate preparation portal, and we offer full course for GATE ME and XE. In addition to that, subject courses are also available for ME, XE, CE, and PI. Engineering mathematics course is available for all stream, and in addition to that, we offer online test series for GATE ME and XE also. So this is our website. You can just check out so that you will get to know more about us. And in addition, we have our own Android app and also iOS app, and you can just go through that also to know more about our courses. Okay. And this is our last year, that is GATE 2021 result from XE. And now let us proceed to the video. And this video is taken from online video course of Endurance Engineering Academy. Right, let us start discussing the problems based on divide and rule policy. That is two-dimensional case. See, we know that in two-dimensional case, what we will do, we will divide it. Okay, so first we will be solving it in x direction, we will solve it in y direction, and finally we will combine it to get the result which we decided to. Okay, now for doing this, like for explaining this method alone, I'm going to do this problem. This problem will be a bit lengthy, and it's not going to be that much useful, or it's not going to be that much what I could say, they won't ask this. I won't say that it is not useful, it's going to be useful, but the same question they cannot ask it in the exam, but they can ask any bits and pieces. Okay, only small part of this question can be asked in GATE exam or even in the ESE prelims exam. Okay, right. So now coming to a particle moving in xy plane with a constant acceleration of 1.5 meter per second square. So acceleration is given as 1.5 meter per second square, and also said that it is constant. Okay, they also said that it is constant, very important, in a direction making an angle 37 degree. So beta, that is angle this acceleration is making. Okay, so that is 37 degree, right? So if I draw it, okay, if I draw it, it will be something like this. Okay, let me use another color. So this is going to be the acceleration vector A, and it is present at an angle 37 degree. Just be with me patiently. This is going to be simple question only, but it will explain you this concept. Okay, right. Now, at a time, and they given that with respect to x-axis, right? That's what I'm doing. With respect to x-axis, it is 37 degree. Okay. At a time t is equal to 0 seconds, the particle is at the origin. Okay, when time is 0 second, okay, let me take an origin. Okay, let me take this is origin 0 comma 0. Okay, the particle was at this origin when the time was 0 second. Okay, when the time was 0 second, the particle was at the origin. Okay, and its velocity is 8 meter per second along the x-axis. So very simple, they said that the velocity along x-axis initially, okay, initially when time is equal to 0 means what? Initial time period, right? When time is equal to 0 means what? Initial time period. So initially velocity along x-axis, okay, velocity along, not velocity along x-axis, velocity is 8 meter per second, and that was present along x-axis. Okay, so this is going to be 8 meter per second, and that is my initial velocity u. Okay, I hope it is clear. So let me take this is x-axis, and let me take this is y-axis. Okay, and where is my what is that? This is, sorry, and this is going to be my velocity. Okay, initial velocity. See, we clearly getting to know that initial velocity was in the direction of x-axis. So what is going to be alpha? Alpha is going to be 0. See, in general, initial velocity will be like this, right? This is going to be the x-axis, this is going to be y-axis. This I am going to take this alpha. But since our velocity was along x-axis, alpha becomes 0. Okay, it's very basic. I hope that you could understand this. Okay, so here velocity was along x-axis, so alpha was 0. Okay, so alpha is 0, and now let me read the question again. Find the velocity and position of the particle as the time is t is equal to 4. So when time is equal to 4 seconds, they are asking us to find out velocity and position, which is nothing but x comma y. Okay, we'll take it as x1 comma x1 comma y1. Okay, x1 comma y1. Okay, now first of all, what I can do, divide and rule policy, right? So let me divide the acceleration in x-axis and y-axis. So what will be x-axis acceleration ax and what will be y-axis acceleration ay? Okay, ax is going to be a is nothing but 1.5, right? So a cos beta and ay is nothing but a sine beta, which is equal to a is 1.5 into cos beta is cos 37 degree. You can just do the calculation. Ay is 1.5, sine beta is sine 37 degree. Okay, why I am doing cos beta here? Because angle known side. Okay, in angle known side I am resolving. So it is cos beta. Okay, so now we got ax and ay. Let me give you the value also. Okay, so ax you are going to get it as 1.2 meter per second square. Okay, if you solve this, you will be getting 1.2, and ay is going to be 0.9 meter per second square. Okay, so we got ax and ay separately. Now what about ux, initial velocity ux? See, this acceleration was constant, so no issues at all. Now coming to ux and uy, initial velocity in x-axis and initial velocity in y-axis. Initial velocity in x-axis, you could see here, u is equal to 8 meter per second, so 8 meter per second. What about initial velocity in y-axis? It is 0, right? It is 0. So clearly it is 0. So initial velocity in y-axis will be 0 and alpha is going to be 0. Now they are asking us to find out final velocities, okay, v and then final position. So how can I do? Initial position was 0, 0. Let us consider it is traveling, okay, it is traveling, it is reaching some position x1 comma y1. Okay, it's reaching some position, so I need to find out this position x1 comma y1 and what is the velocity. Okay, what is the velocity? So first what I can do, I can find out velocity in x direction and velocity in y direction separately. Later I can use this formula, v is equal to root of vx square plus vy square to get v. Okay, very simple, right? So that is ultimately we are going to do. Similarly, we can find out the point also, at what point it is lying. Okay, we will start doing it one by one. Right, so this is what we got, right? So this is our y-axis, this is our x-axis, this is the initial point 0 comma 0, this is the final point x1 comma y1, this is the displacement. Okay, we know that displacement is nothing but the shortest distance, so connecting this point and the final point x1 comma y1 is s, and the final point we are reaching at a time t is equal to 4 seconds. Okay, so initial velocity in x direction, initial velocity in y direction. Similarly, we know that what is initial acceleration in x direction, initial acceleration in y direction, all those things. And finally we need to find out this like this two things, right? So we will be finding out vy and we will be finding out vx. By solving it we can find out v. So first I will start with x direction. So why I am doing this, why I am doing separately, divide and rule policy which Newton given to us. So just divide it and find out x direction, y direction separately, then I can simply find out the resultant. Okay, right. So now first we know that time taken is 4 seconds, no issues at all. Now what formula I can use? I know initial velocity in x-axis, I know acceleration along x-axis which is constant. So for a constant acceleration we can use those three equations. I hope you remember what are those three equations. V is equal to u plus at, s is equal to ut plus 1 by 2 at square, and v square is equal to u square plus 2as. Okay, these are the three equations which we need to use, and from this three equation, which equation will suit us now? We know velocity, we know acceleration, we know time taken also. So simply I can use the first equation, vx is equal to ux plus ax into t. Why I am taking ax ux? Because I am finding it only for x direction. So what is vx? Vx is something which I need to find out, which is equal to, what is ux? Ux is already known, 8. And what about acceleration in x direction? 1.2. Time taken is 4. Okay, so this is going to be 4.8 plus 8, which is 12.8 meter per second. So let me just mark it here. Vx is equal to 12.8 meter per second. Okay, now what about other data which I want? I want x1 also, right? I want x1 also. X1 is what? X1 is nothing but distance covered in x-axis. Okay, distance covered in x-axis. For reaching this point, for reaching this final point, let me take the final point to be P. Okay, from origin O to reach the final point P, we have to cover x1 distance in along x-axis. So, what formula I can use? Simply I can use the second formula. So x1 is equal to uxt plus 1 by 2 into axt square. Okay, ux and ax are nothing but velocity and acceleration in x direction. So ux is nothing but 8 and time is 4 plus 1 by 2 into ax, which is 1.2, and time taken, which is 4 square. Okay, why I'm taking x1? Because I'm finding only in x direction, so I'm taking it as x1. So what will be the final answer which I'm going to get? X1, which is going to be 41.6 meter. Okay, so x1, okay, this is going to be 41.6 meter. Just solve it, you will be getting it. Okay, simple. So we solved x direction and we got vx and x1. So now let me go for y direction. Okay, let me go for y direction. So in case of y direction, what are all the things which I have? Again, I have acceleration in y direction. Velocity is anyways 0, and the time taken is not going to vary, right? So time taken is going to be 4 seconds only. So what I can use? Simply I can use the first equation again. So here now y will be equal to uy plus ay into t, okay, which is equal to, what is velocity in y direction? It is 0, initial velocity. Acceleration, constant acceleration, which is 0.9 into time taken, which is 4. See, one important point you need to understand: this question, they given that acceleration is constant, so only I'm using this 3 equation, don't forget that. Okay, so by solving this, 0.9 into 4, it's going to be 3.6 meter per second. So velocity in y direction is 3.6 meter per second. Okay, now coming to next case, y, which is equal to, we can use this formula, right? We can use this formula. Okay, y is nothing but what? Y1, in fact, y1, which is nothing but this distance. Okay, this distance is y1. Okay, so instead of s, I can use y1, which is equal to uyt plus 1 by 2 ay into t square, which is equal to uy is 0 anyways, plus 1 by 2 acceleration y direction is 0.9, okay, into time taken is 4 square. Okay, so 0.9 into 4 square, that is going to be 7.2 meters, because we are finding out distance. So y1 is equal to 7.2 meters. So we found out all the data, right? We found out the velocity, we found out position also. What we will do, we will find out this angle. Okay, we will find out this angle also, and we will find out theta also. Okay, if you want, if you wish to, you can find out theta also. Okay, and if you want to find, if you wish to, we can find out alpha also. Just for just, it is what I could say, just for like making you to understand how to solve, but they are not asking that. But anyways, we will solve it. So now the final state we reached, right? So this is our final point, right? So we got that x1 was 41 and y1 was 7.2. So what will be my s? What will be my displacement s? Simply from this triangle OP, and if I take this is q, so from OPQ I can write s is equal to root of x1 square plus y1 square, which is equal to root of 41.6 square plus 7.2 square. Okay, so just solve this, you will be getting it as 42.21. So s is equal to 42.21, okay, meters, of course. Now what about theta then? Theta is what? Theta is nothing but the displacement vector. Okay, theta is nothing but the displacement vector's angle. So let me show you here. Right, so this is the displacement vector, right? S, okay, S vector. So I'm showing you here, and this angle, okay, this angle, or I can show you here, okay, this angle theta. Okay, let me erase this, I will show you here, so that will be easy for you. So this angle theta, okay, this angle theta, this angle theta, or this angle theta. Okay, this is our displacement vector, S vector. So how can I find out the theta? Simple, this is y1, this is x1. So tan theta, okay, that is angle made by the displacement vector with respect to x-axis, is going to be opposite by adjacent. So theta will be tan inverse of y1 by x1. So which is nothing but tan inverse of y1. Yeah, we got it here, 7.2 x1 is 41.6. So solve this, you will be getting it. So tan inverse is 9.81 degree. So that is theta. Okay. Now we got theta. Now I can proceed for s. Okay, that is I can proceed for velocity and then velocity vector, and then I can proceed for what is that? The angle. Okay, so first of all, how to find out the velocity vector? Very simple. V will be, I'm sorry, V will be equal to root of Vx square plus Vy square. So final velocity vector, that is velocity, will be equal to the resultant of x direction and y direction velocity. So that's going to be Vx is 12.8 square plus Vy is 3.6 square. Okay, so that is going to be root of this, which will be 13.3 meter per second. Okay, so we got velocity also. Now finally alpha, so that is going to be tan alpha, which is equal to, how can I find? See, this is velocity v, and this will be Vy, and this will be Vx, and this angle is alpha. Okay, so tan alpha is opposite velocity vector by adjacent, so which implies alpha is equal to, okay, alpha is equal to tan inverse of Vy by Vx. We already got Vy and Vx, right? Vy is nothing but 3.6 and Vx is nothing but 12.8. Okay, so tan inverse of 3.6 by 12.8, that is 15.7 degree. So this is big question, but overall from this question you just need to understand the procedure. Okay, so what is the procedure for solving a two-dimensional problem? I need to solve x separately, y separately, then combine it to get the final velocity or final displacement, and similarly angle, whatever you want you can determine by solving it separately and then combining it. Simply divide and rule policy. So let us go for the next question. A particle moves along a path y is equal to x square minus 4x plus 100. Okay, let me write it down here. Y is equal to x square minus 4x plus 100. Okay, starting with an initial velocity. So this is the initial velocity. Okay, so that is v naught, which is equal to 4I minus 16j. Okay, from this what we can get? We can get that ux. Okay, let me write it properly. Okay, ux, that is velocity in x direction. Okay, initial velocity in x direction is going to be 4, and similarly initial velocity in y direction is going to be minus 16. Okay, this is 16, right? So minus 16. Okay, both are in terms of meter per second only. Okay, now if Vx is constant, okay, that is velocity in x direction is constant, what does it mean? It's not going to vary, always it's going to be 4 meter per second only. So Vx constant means, what is the other thing I can say? We know that Ax is nothing but, okay, or simply velocity is nothing but what? Rate of change of displacement. Acceleration is nothing but what? Rate of change of velocity. Now ax means it is rate of change of velocity in x direction. So velocity is already constant, so ax will be 0. Okay, which is nothing but uniform velocity in x direction. So acceleration becomes 0 in x direction. Now coming to the question, they are asking us to find out velocity in y direction and acceleration in y direction. Okay, and at they given the point also at x equal to 16 meter. Okay, let us find out. First of all, what is velocity in y direction? What is the general equation? General equation is going to be dy by dt, right? Differentiation of y with respect to time. We already know y. Okay, we already know y. So if I differentiate this, left hand side is going to be dy by dt. Right hand side, I'm differentiating with respect to time. Don't forget that. Okay, so differentiation of x to x square is going to be 2x into dx by dt. I need to do, again, I need to follow the cyclic rule. I'm differentiating this totally. If I do that, it becomes 2x. Okay, now x is also a function of time, right? So I need to differentiate if I differentiate this totally x square, it's going to be 2x. Now I need to differentiate only x, so that's going to be dx by dt. Okay, now coming to this plus, what about minus 4x? I'm sorry, minus, right? Minus 4x. Okay, so let me proceed. Minus differentiation of x was straight away it is dx by dt. Okay, differentiation of x was straight away it is dx by dt plus differentiation of constant, which is 0. What is dx by dt? Simply it is vx. Vx is nothing but rate of change of displacement in x direction. So finally, what is the equation I'm getting for vy? Vy is equal to 2 times of x into dx by dt is vx, I'm very sorry, dx by dt is vx, right? Okay, so Vx minus 4 into this is also Vx. Okay, now we already know Vx is going to be constant and that is going to be 4 meter per second. Always it's going to be constant only, right? So if I substitute it here, 2 times of, at what distance I need to find out? I need to find out at 16 meters, right? At x is equal to 16 meters. So 2 into 16 into let me write it properly, I'm sorry, 2 into 16. Okay, so 2 into 16 is the displacement into vx value was 4. Okay, minus 4 into 4. Okay, so if I solve this, I will be getting vy directly. Okay, directly I will be getting vy, so that's going to be 112 meter per second. Okay, so velocity, y direction velocity when x is 16 meter was 112 meter per second. Okay, so we got that. See, straight away we can give the answer, right? Straight away I can say that there is only one option where I am having velocity in y direction, so that is going to be option B. Okay, but anyways, just we are going to be in the learning, we are in the learning process, so let us find out how to find out acceleration also. Okay, so now we got velocity, right? So what I need to do, I need to find out acceleration in y direction. Okay, acceleration y direction is going to be simply differentiation of velocity in y direction with respect to time. Okay, so we already got this. Okay, so if I differentiate this, I can use that UV method. Okay, I hope you will able to recollect it. I can simply use the UV method. So I'm differentiating with time, right? So I can take one as u and another one as v. Okay, so if I keep 2x as constant, okay, and if I differentiate vx with respect to time, plus keeping vx constant, I'm differentiating 2 anyways is constant, I'm differentiating x, okay, dx by dt, minus 4 into dvx by dt. Now listen carefully. We already know, we already know one thing. We already know one thing that what is this? Here it is. Vx is constant, which means ax is 0, right? So ax 0 means dvx by dt will be 0. So which means this term is 0 and this term is 0. So we have 2 times of vx into dx by dt, which is again vx, right? So which implies 2 times of vx square, which is equal to 2 times of what is vx? Velocity in x direction. That is going to be where it is, where it is, where it is, where it is. Here it is, 112. We got it right. Sorry, this is velocity in y direction. Where it is velocity in x direction? Here it is 4. Okay, so 4 square. So 4 square 16 into 2 is 32 meter per second square. So we got the answer. We already know the answer. I'm just giving you the method so that it will be useful for you when you do any other questions.